Optimization is a process of methodology of making something such as a design system or decision as fully perfect in mathematical fields. Optimization is the mathematical process used for finding the maximum and minimum value. The generalizations of optimization technique and theory to other formulas will involve the applied mathematics. Optimization, also known as a linear programming, introduced by Nino Kantorowicz in 1939. With the progress in mathematics, optima are identified in calculus-based formulated by Fermat and Lagrange, while Newton and Guess proposed iterative methods for moving toward an optimum. Optimization's problem is widely useful in many fields, such as economic, finance, operation, research, and more. By implemented an optimized process, it will improve efficiency, make accurate information, and performance monitoring and accountability for a company. 1.2 key concept. In application in the business and economy, every decision making will be applied in a mathematical technique to get more profit in order to earn money without loss. The quantity of product manufactured and sold, selling price, and cost for produce the product should be managed properly. The optimization problem is in form of function with some set and often represented a range of choices available in a certain situation. The function is in single or more variable, allow the comparison in different choices and to identify the best value to maximize the profit. 1.3 Objective. The objective of this study are to determine the selling price, quantity, and cost of a product to maximize the profit in business and economics by using the derivative technique. In this methodology, there are 3 steps to identify the maximum and minimum value. First step, critical point. Let z equal to f of x, y and differentiable the function respect to x as f of x and respect to y as f of y. To determine the value a and b for the critical point a, b of the f functions, let f of x equal to f of y equal to 0. Second step, to determine the local maximum, local minimum at center point, the second partial derivative are applied. The formula is d equal to f of xx multiply f of yy minus f of xy squared. There are 3 scenarios to identify the critical point. The first is if the d of ab greater to 0, f of xx greater to 0, the critical point is local minimum. Second scenario, if d a of b greater to 0 and the f of xx is smaller than 0, then the point is the local maximum. The third scenario is if the d of ab is smaller than 0, then the point is the center point. The last step is absolute value. An absolute value is determined in critical point and boundary point. The largest of these values in critical and boundary point are absolute maximum value. The smaller of this value is absolute minimum value. Boundary point is determined in a range of x and y. By using x equal to a and x equal to b along x-axis and differentiable the f of xy respect to y to determine the boundary point. If the f of y-axis, the boundary point is a0 and b0. If the f of y does not exist, means that there is no boundary point along the x-axis. Use y equal to c and y equal to d along the y-axis and differentiable the f of xy respect to x to determine the boundary point. If the f of x exists, the boundary point is 0c and 0d. If the f of x does not exist, there is no boundary point along the y-axis.
So now we are going to look into the application in business field. So for the background, in the theory and application, we often want to maximize or minimize some quantity in various fields. So in this business field, we are going to look on the maximization, where as a businessman or as a businesswoman, they normally will set their daily target on the profit to continue operate their business in the future. So particularly, we have 3 important elements to obtain the profit function. The first one is profit, the next one is revenue, and the third is cost. So to find the profit function of the business, fxy, we're going to multiply the item sold with the revenue, where the revenue is price minus cost. Let's say we have 2 variables which are x and y for item A and B. The profit function will look like the slide. fxy is equal to item sold multiplied with price minus cost for item A plus item sold multiplied price minus cost for item B. So after that, we are going to do the partial derivative for the first partial derivative and the second partial derivative to find the critical point. And then we are going to compute the D, where it will help us to identify the maximization profit of item A and item B. Look in the example. So there's a situation where a grocery store carries two brands of fish feed. One is local brand and one is international brand. So for the local brand, it will obtain at the cost of 30 ringgit per can, and the international brand will obtain at the cost of 40 ringgit per can. So the grocer estimate that if the local brand is sold for X ringgit per can, while the international brand is sold for Y ringgit per can, then approximately 70 minus 5x plus 4y cans of local brand and 80 plus 6x minus 7y can of international brand will be sold each day. So now there is a problem where how should the grocer estimate the price of each brand to maximize the total daily profit from the sales of fish feed. So first we wish to find the profit from the sales of the fish feed. Since we know that total profit is actually equal to the profit from the sales of the local brand plus the profit from the sales of the international brand. So we could say that the total daily profit from the sales of the fish feed is given by the function fxy is equal to item sold for local brand multiplied with the profit per item plus item sold for international brand multiplied the profit per item. So we plug in the function 70 minus 5x plus 4y for local brand, and then the price is estimated as x and minus the cost is 30 ringgit plus the function of the item sold for international brand 80 plus 6x minus 7y multiply with the cost estimate with y minus 40 for the cost. And we will obtain negative 5x squared plus 10xy minus 20x minus 7y squared plus 240 y minus 5300. So next, we are going to do the partial derivative with respect on x and y for the function, and we will obtain fx is equal to negative 10x plus 10y minus 20, while for fy is equal to 10x minus 14y plus 240. For the third step, we will let the fx equal to fy is equal to 0, where it helps us to determine the critical point. So from the partial derivative, from the first partial derivative, we will obtain negative x plus y equal to 2 for the fx equal to 0, and 5x minus 7y equal to negative 120 for fy is equal to 0. So after that, we are going to solve the simultaneous equation to get the critical point. So we are going to use the y equal to 2 plus x to sub in into the 5x minus 7y equal to negative 120. So after sub in the y, we will obtain x is equal to x is equal to 53 and y is equal to 55. So for now, we can conclude that the critical point is 53, 55. And now to identify the function has a relative maximum, we need to apply the second partial derivative after the first partial derivative. So we're going to find fxx, fyy, and fxy. So for fxx, after we derive fx, we will obtain negative 10, fyy we will obtain negative 14, and fxy we will obtain 10. So after this, by the fxx, fyy, and fxy information, we can determine the d, where dxy is actually equal to fxx times fyy minus fxy in bracket square. So we plug in the information that we obtained just now, and we will get 40. So we can conclude that d 53, 55 is equal to 40, where it is larger than 0, and fxx 53, 55 is negative 10, which is less than 0. And this proves that it is a relative maximum. So from the calculation just now, we can conclude that f has a relative maximum when x is equal to 53 and y is equal to 55, which means that the grocer can maximize the profit by selling the local brand of fish feed at 53 ringgit per can, and for the international brand, we can sell it at 55 ringgit per can.
My name is YIAN. Number metric 271316. I'm gonna present 3.2 application is economy field. Background. Absolute maximum for this function represent a straightforward way of maximizing profit. A profit function z equals to fxy with a rectangular d has been considered, while x and y represent the number of units sold and the number of hours of advertising respectively, while rectangular d represent the domain of the function. In this case, first derivative test is using to determine the critical point in d, and rectangular d is to find the endpoint of d. The critical point and endpoint of d is using to find the absolute extrema of the function. Example in economy field. Property company have developed a profit model that depends on the number x of gold balls sold per month, measured in thousands, and the number of hours per month of advertising y according to the function z equal to fxy equal to 48x plus 96y minus x squared minus 2xy minus 9y squared, where Z is measured in thousands of ringgit Malaysia RM. The maximum number of golf balls that can be produced and sold is 50,000, and the maximum number of hours of advertising that can be purchased is 25. Find the values of X and Y that maximize profit and find the maximum profit. First, finding the critical point of F on each domain. Therefore, we first calculate fxxy and fyxy. fxxy equal to 48 minus 2x minus 2y, while fyxy equals to 96 minus 2x minus 18y. For critical point, setting fxxy equal to fyxy equals to 0. By using substitution, x equals to 21 and y equal to 3, therefore critical point equals to 21 and 3. From the question, we can know that domain of this function for x is in between 0 to 15 and for y is in between 0 to 25. Figure 1 shows the graph of the domain of the function for fxy. For L1, it shows that y equal to 0, and we can substitute y equal to 0 to the function f. And we could get the 48x minus x squared. By using first derivative test, we can get 48 minus 2x. After that, we equal it to 0, and we will get x equal to 24. Therefore, critical point equals to 24, 0, and this point is in the domain of f. Same step is using for L2 and L3. The critical point for L2 equals to 15 and negative 2 over 9. This point is not in the domain of f. Well, L3 critical point equals to negative 1, 25. This point is not in the domain of f also. Same step are using for L4. Therefore, the critical point for L4 equals to 0 and 16 over 3. This point is in the domain of f. From the rectangular D, the endpoint is located at 0, 0, 15, 0, 15, 25, and 0, 25. Critical point and endpoints are using to construct the table to find the fxy. From the table, we can conclude that the absolute maximum is 648, which occurs at 21.3. Therefore, a maximum profit of 648,000 is realized when 21,000 golf balls are sold and 3 hours of advertising are purchased per month.
So moving on, I will be presenting the conclusion for our group project, which is the application of multivariate calculus in maximum and minimum value. So in our group report, optimization is the main topic that has been discussed. Optimization theory can be implemented in a different field in order to obtain, maximize, or minimize the quantity of a function. Investigation about the application of optimization that is related to the business field and economic field are conducted as our case study to understand how optimization play an important role in identifying the output in the marketplace to maximize the profit, reduce loss, and properly arrange the production cost of the product. In the first case study, which is the application in business field, the problem statement is to identify the price of each brand to maximize the total daily profit from the sales of fish feed. And in this case study, the first and second partial differentiate tests are carried out to identify the pricing of each product to maximize the profit. Throughout the investigation, the result that we obtain is by selling the local brand fish feed at 53 ringgit per can and international brand at 55 ringgit per can to maximize the profit of the grocer. While in second case study, which is the application in economic field, the problem statement is to identify the number of golf ball and the number of advertising hour per month in order to achieve maximum profit. And as we know that the maximum number of golf ball that can be produced and sold is actually 50,000, and the maximum number of hour of advertising that can be purchased is 25. So in order to investigate the case study, the absolute maximum for the profit function is obtained to identify the maximum amount of the profit earned. And a profit function with a rectangular D has been conducted in this study. To identify the absolute maximum for the profit function, the first derivative test is used to identify the critical point in D, while rectangular D is used to identify the endpoint of D. And eventually, the result obtained for second case study is the maximum profit of 648,000 is achieved when 21,000 golf balls are sold and 3 hours of advertising are purchased per month. As a conclusion, the optimization method is commonly used in the business and economic sector in order to maximize their profit, reduce business loss, identify production costs, improve business efficiency, and etc. That's all for our presentation. Thanks for watching and have a nice day.